As for the volume, volume is the amount of space which is occupied by the matter. And in most laboratories, when we want to measure the volume, we use the standard units, either liters or milliliters. And the conversion is between the liters and the milliliters. Of course, the liter is a bigger unit because 1 liter is 1,000 mils. So this is the conversion. And also, the volume can be measured in cubic centimeter. So 1 cubic centimeter is equivalent to 1 milliliter. We do use multiple glasswares for measuring the volume. Some of them are more accurate than the other. So if you want very accurate measurements for the volume of the water, normally we use a burette. We put the liquid in the burette and we dispense how much we need. The burette is graduated, so it gives you a precise measurement of the volume. Same thing for the pipette in there. Normally, what we do is we get the pipettes with fixed volume. So we have pipettes of 10 mils, 20 mils, 5 mils. They do have a line in there, and this line indicates the volume of the liquid inside. So normally what you do is if you want a 10 ml solution, you grab a 10 ml pipette and you fill it to the mark. And this guarantees that you get exactly 10.00 milliliters. Another glassware is the volumetric flask. Same idea as the pipette in there, but you put it in the flask and there is a mark in there that indicates exactly how much you have in that volumetric flask. Volumetric flasks, they come with different capacity. They can be 10, 5, 1 mil, 2 mils, etc., etc. It depends on the volume that you need. The least precise one is the graduated cylinder, though. The graduated cylinder, even though it's a graduated, but the volumetric flask, burette, pipette, and syringe, these are more accurate than the graduated cylinder. So we're going to apply the same concept as we used before. It's just we are introducing a conversion factor that eliminates the starting unit and introduces the unit that you want to measure. So the question is here, how many microliters are there in 1 mils? This is given. So I'm going to give you 1 liter is that much mils and 1 mil is that much microliters in there. So you already know, you just need to put this equation in there because you want to go from the 1 liter, because this is what's given. You're starting with the 1 liter, so you are going to start with the liter in there. You want to go into microliters, but to go into the microliters, you do have to pass by the mils. To go from 1 mil to the to go from the liter to the mils, you're gonna go ahead and multiply by 1,000. And to go from mils to microliters, you're gonna also multiply by 1,000 in there. I'm starting with one significant figure, so my answer is going to be one significant figure. So I'm starting here with 1 liter, right? Times. I want to cancel the liter, introduce the mils, so it's going to be 1,000 mils. Whatever I'm finding is in the numerator. Whatever I'm canceling is in the denominator. So I'm going to cancel the liters in there. And then I want to go from the mils to the microliter. So I'm going to introduce the microliter and I'm going to cancel the mils in there. So I know that 1 mil is 1,000 microliters. So I'm canceling those units. And my answer in this case is going to be 1 times 1 point times 10 to the 6, and that is going to be a microliter. This is another example here in the SI system of units. The basic unit of the volume is the cubic meter. Okay. I know that I have a relationship between the mils and the cubic centimeter. So up to a certain point, I have to change the cubic meter into a cubic centimeter to relate it into mils and liters. A volume of 1 meter cube is equal to which of the following? So you see, all my answers are in liters. So I would need to change the 1 meter cube into a centimeter cubed. And then from the centimeter cubed, I need to simply change that into a mil, then into a liter. So I'm going to start with whatever is given for me, which is the 1 meter cubed. This is 1 sig fig, okay? So answer all of these actually all of the choices that you see, they are one significant figures. So I'm going to start with meter cubed. So I do have a 1 meter cubed in there. And I want to change the meter cubed into a centimeter cubed. So I want to change the meter cubed into a centimeter cubed. There's direct relationship between meter and centimeter. Normally we pass by smaller unit, which is the decimeter, to go into the smallest, which is the centimeter cubed. To go from here to here, we multiply by 10 to the 3, here by 10 to the 3. So basically we're multiplying by 10 to the 6. This is what we're doing. So we're going to go ahead and multiply by 10 to the 6 centimeter cubed for every 1 meter cubed in there. So now I introduce the centimeter cubed. Now I want to change the centimeter cubed into a 1 mil, knowing that 1 centimeter cubed is equal simply to 1 mil. Okay, so here I change it into 1 milliliter. And then I want to change the mil into a liter. Why? Because my answers are in liters. If my answers were in mils, I'm going to stop here. But since my answers are in liters, I need to continue. And I would need to change the mils into a liter. So I know that since I need the liters, it needs to be in the numerator. That is equivalent to 1,000 milliliters. Here you go. And then my final answer is going to be 1 point times 10 to the 3 liter. Okay, same idea. We're going to convert 4.61 times 10 to the 2 microliters to mils. This is the given for me. So since I'm starting with microliters, I want to turn it into a milliliter. The microliter is a very small unit. So in the milliliter is a larger unit than the microliter. So here, what do I need to pass? Since I'm given that, I'm given from a micro to a liter. So I need to use that. And then I can change the liter into a milliliter. So starting with 4 point, this is your starting number. So I'm starting with this. Always start with the given. Times 10 to the 2 microliter. When I change that into a liter, so I know that 1 liter is 10 to the 6 microliters there. And then I want to change the liter into a mil by knowing that 10 to the 3 milliliter is equal to 1 liter. So this way I'm going to cancel the liter, I'm going to cancel the microliter and be left with just the mils, which is 4.61 times 10 to the minus 1 mils. For temperature measurements, we have 3 different temperatures, the Celsius, the Kelvin, and the Fahrenheit. And this is the relationship over there. These are the 3 equations. Again, please don't memorize. These equations will be given for you. So you can simply change from Celsius to Kelvin, Celsius to Fahrenheit, and these are 2 for Fahrenheit in there. Okay. Let's have an example. Absolute zero is the temperature that beyond which nothing is moving. So no molecule, no atom is moving in here. So this is the smallest temperature that is actually non-reachable. Okay, at this temperature, every living organism and every living atom molecule is gonna freeze. It's gonna stop vibrating. We know that atoms and molecules, they are constant vibration and constant motion, but once they reach absolute zero, there will be no vibration at all. So that temperature is hard to reach, and it's equivalent to minus 273 Celsius or minus 459 Fahrenheit. Okay, so an example over here, it is not uncommon for temperatures in the Canadian plains to reach minus 60 Fahrenheit and below during winter. What is the temperature in Celsius and Kelvin? I mean, you are going to be given those equations, so just go ahead and plug in the numbers in there. So I know that this is minus 60 point minus 32 divided by 1.8, and my answer is going to be minus 51 degrees Celsius. So you're given over here minus 60 Fahrenheit. You want to change it into a Celsius in there. Minus 60 is a one significant figure, so your answer has to be one significant figure, so that is going to be minus 50 Celsius. But see, with the temperature, you need to be really accurate. So normally what we do with temperature measurements, we just drop the significant figures in there, and we don't change the answer into the appropriate significant figure, because we know that there's a big difference between minus 51 degrees and minus 50 degrees. So I'm just going to go ahead and keep that as minus 51 degrees and will not follow the significant figure for my answer. Okay. So K over here is Celsius. So to change from Celsius to Fahrenheit, just add 273. And your answer here is going to be minus 51 Celsius plus 273.15, and that is equal to Kelvin in there. And as you see over here, I am not following the significant figure because this is a temperature and it's supposed to be a constant measurement. So this is why. Convert 77 Fahrenheit to Celsius. So you have your Fahrenheit. Just make sure that you choose the right equation. Plug in your given and then get your Celsius in there. Convert 22 degrees Celsius to 54 Fahrenheit and Kelvin. I did one example over here. Let's do this one. So let's do the 22. I did the 54 on the other side. So the 22, so this is equal to 1.8 times 22 Celsius plus 32. You can plug all of those into your calculators. You can use your calculators, of course, in the exam. Just make sure that we are using a non-scientific calculator, please. Okay. I mean, non-programmable calculator. So K is equal over here. Once you want to change it into Kelvin, then I know what's the Celsius, which is 22 degrees Celsius. Just add 273, and it's going to be 295 Kelvin. It's 273 actually 0.15, but you don't have to be that precise. So we normally drop the 0.15 and we just use the 273, and answer is just fine. Okay. The next topic is density. So the formula for the density is the mass divided by the volume. Density is normally used to measure to measure simply the liquids and to measure the solids. So for liquids, it's easy. I mean, you can go ahead and get the volume for the liquid, mass the liquid, get the mass of the liquid in there, and divide them over each other, and simply get the density. For the solids, what do you need to do? Because for the solids, how can you get the volume of the solid? So normally with the solid, what we do is we use a displacement method in order to determine its volume. And this is going to be illustrated in the lab. So you're just going to grab a container, whatever that is, and that will have a certain amount of solution in it. Okay. So let's say, for example, if I have this cube in here, it's a solid, and I want to go ahead and get its volume. So what you do is you measure the initial volume of the liquid in your container, and then go ahead and drop your cube in there. So when you do that, the level of the liquid is just going to rise a little bit, and it's called a displacement. This is called a displacement value in here. So that rise in the level of the liquid, you can go ahead and measure that, and this is equivalent to the volume of the solid. So when we say density is equal to mass over the volume, we can rearrange that, and we can get with two more different equations with the mass and the volume to be the unknowns. So mass is the density times the volume, and the volume is the mass times the density. All of those will be included in your cheat sheet, so you don't have to memorize any. Okay. Density, of course, is going to vary with temperature. So we all know that the temperature or the density of water is equal to 1 grams per mils, and this is at room temperature. So 4 degrees or 25 degrees, the temperature or the density is close to 1 grams per mils. But as the water is heated, what we're going to have here, the mass is going to stay the same. So this is the mass, and this is the volume in there. So see, when the water is heated up, this is high temperature. This is over here is low temperature or normal temperature. So if it's normal, it's 25. If it's low, it's 4. At high temperature, you know that the particles in the water, they are going to vibrate, and they're going to vibrate more. You are heating your solution. So as you're heating your solution, the particles are going to expand, right? So when they expand, the volume is going to increase. So notice here that the volume is more than the volume at a low temperature. So as the volume over here decreases, or sorry, increases, here is increasing, the density is going to decrease because the density and the volume, they are inversely proportional to each other. This is your equation in there. So as the volume increases, as the density is going to decrease, and vice versa. As the volume decreases, as the density is going to increase, because the density and the volume are inversely proportional to each other, assuming the mass is constant. Okay, so if the mass is constant, the density is going to vary with the volume, and it's going to be inversely proportional to that of the volume. This is a simple example of density calculation. So starting with 13.5 milliliters of a sample in there of an unknown liquid has a mass of 12.4 grams. What is the density of the liquid? You can go ahead and substitute. I mean, I do have the volume, which is 13.5. I do have the mass, which is the 12.5. So you can go ahead and this is grams divided by 13.5 milliliter. You can substitute that, and your answer is going to be 0.199 grams per mils. The grams per mils are the units that, please don't forget them, okay? So over here we have 3 significant figures. And this one is 3 significant figures, so our answer is going to be 3 significant figure, and this is going to be my 3 significant figures in there. So remember the zeros before the decimal, we don't count those, okay? So your answer here is going to be 3 significant figures. The density of ether is that much. What is the mass of that volume of ether? So since we need the mass, right, we can rearrange. So we say that cross multiply density times the volume is equal to the mass, right? So we need the mass in there. We have the density, we have the volume. The density is 0.714 grams per mils, and the volume is 25.0 mils in there. So the mils and the mils are going to cancel out, and you can get the mass, which is 17.9 grams. Your significant figures are 3 significant figures. This one is a 3 sig figs as well. So your answer has to follow 3 significant figures. The density of oxygen at 0 degrees is that much. What is the volume of 32 grams of oxygen? Again, we do the same thing in there. We're just gonna make an equation of the volume to be the unknown. So I know that density times the volume is equal to the mass. I'm going to divide by density here. So I know that the volume is the mass divided by the density. This is my new equation. I have the mass, which is 32 grams, and I have the volume, which is 1.429 grams per liter, and my answer is 22.40 liters. Okay, so here we have a 20.0 sample liquid is put into an empty beaker that had this mass. So the empty beaker has a mass of 31.447 grams. Okay, so the beaker and the contained liquid were weighed and had a mass of 55.8891 grams. Okay, so the liquid, so we had an empty beaker, it had a mass. We added the liquid in it. So now if we want to mass the beaker, it's going to be both the mass of the empty beaker plus the liquid in it. So it's going to be two things, right? So the mass of the beaker plus the liquid, it's given to be 55.88 or 891. I needed just the mass of the liquid, you guys, because when you get the density, it's going to be the density of the liquid, so it's going to be just the mass of the liquid. So to get the mass of the liquid, just subtract these two from each other. So you're going to do the 55.891 minus the 31.447. You always subtract an absolute value and you do the bigger minus the smaller. You can never have a negative mass. Okay, so the answer in this case is going to be a 24.444. Just notice that after the decimal point, this is a subtraction. You have three digits after the decimal point, so your answer has to be 3 digits after the decimal point. So we're going to carry this over here, 24.444 grams divided by 20.00 mils, and that is equal to that much grams per mils. Okay, in this problem over here, you are given the mass of a 10-gram object, okay? And you have different objects in there. You have gold, you have sulfur, you have water. All of them, they weigh 10 grams. So the mass is constant. However, the volume is different. So the volume of the gold is less than the sulfur, is less than the water, okay? And on the other hand, you have another case where you have 3 molecules in there, and those molecules, they have a constant volume, but their mass is going to be different. Just remember over here that density is equal to the mass divided by the volume. So we have two different cases in there. When the mass is constant, so see here the mass is constant, we say that as the density increases, the volume is going to decrease. Okay, so here the volume is going to decrease. So for the gold, I'm expecting the gold to have the highest density in there because its volume is less. So see, the density of the gold has a higher density compared to the others. On the other hand, if the volume is fixed in there, so if I'm fixing the volume and here it happens to be V equal 1, it's not necessary that the volume is 1, but here volume is equal to 1. Because the volume is equal to 1, I can replace the volume here to be 1. Then I'm going to end up with a relationship that the density is equal to the mass. So this is going to be the same. So density is equal to the mass because the volume is equal to constant. And if the volume is not 1, then the density is going to be proportional to the mass. So this means that as the mass increases, the density is going to increase. Okay? So let's write it down that if V is different than 1, okay, if V is different than 1, then the density is proportional to the mass. This means that as the density increases, as the mass is going to increase as well. So if I am looking over here, I would say that gold will have the highest density compared to the sulfur and the water because the mass of the gold is going to be the highest. Let's have an application of problem over here. So aluminum, gold, and iron have densities of 2.7 gram per cc is centimeter cubed, 19.2 and 7.874 gram per centimeter cubed. So I'm just listing whatever it's given over here. Suppose a 5 gram of each metal were obtained. So the mass is constant. You guys, the mass is constant. So I know if the mass is constant, as the density increases, as the volume is going to decrease, right? Okay, so it's good as the density increases, as the volume is going to decrease. So this means that, so density over here increases. So here the density is going to increase. So this is the highest density, so the volume has to be the smallest in there. So I am actually expecting that 1 is going to be gold, right? So 1 over here is going to be gold. 2 is going to be aluminum. and the 3 is going to be iron in this case, okay? Because iron, so 3 is going to be iron in this case. Aluminum is the one which is the lowest density, so it's going to be it's going to have the highest volume. And gold is the one with the highest density, so it's going to have the lowest volume. So this is going to leave this to be iron in there. So as we said, 2 is aluminum, 1 is gold, and 3 is iron. You guys, make sure this is the end of the chapter. Make sure you go over the homework, and I've posted the complete answers for the homework, but the homework is still due. Okay, so please make sure that you submit your homework. And if you have any questions, please let me know.